Good evening, all. Coming to you tonight with a few common mistakes regarding exponents. Now, let's just review what we mean by exponents. Um, an example, when you see this notation, we use 3, and 3 is, we'll call 3 the base. We could choose any number we want. The 3 is referred to as the base. If we write this as 3 raised to the 4 power, the 4 right here is the exponent, okay? 4, this little guy right here is the exponent. A lot of people just call it a power. And the word raise is common language here. But what does this mean? This literally means, and I'll use dots here to connote multiplication, but 3 times 3 times 3, like that. Okay, so you can think of exponentiation as repeated multiplication. Okay, now, as far as the types of mistakes that can occur when you're using exponents, I'll illustrate with this same example. Let's say we have the same 3 raised to the 4th power, but then that entire quantity we want to raise to the 2nd power. Okay. Now, a real common mistake, and I'll use the notation right here, does not equal. Y'all know this is the equality symbol. If you put a little slash to it like that, that means does not equal. So this does not equal to 3 to the 6th. Again, it's some people see this and think you're supposed to add the 4 and the 2, but all you have to do is really, what does this really mean? And let's just write it down right underneath, because I try to illustrate understanding versus rote memorization here, so you'll see why the rules actually hold up. So right here we have 3 to the 4th squared, but what does that 2 mean? It means that we write down 3 to the 4th twice. Okay. I'll go ahead and use the parentheses. Some people skip the parentheses. In my view, it kind of enhances the readability of the expressions here. You could do without the parentheses, but so 3 to the 4th squared means 3 to the 4th twice. You see this 2 right here means to write the object or the argument in the parentheses twice. So 3 to the 4th gets written twice right here. Okay, but what does that mean? We have 4 copies of 3 right here and 4 copies of 3 right here. So that's 4 plus 4, which is 3 to the 8th. Okay. So you see, indeed, on a problem like this, you actually add the exponents. Now, a related problem would be if you had 3 to the 4th. And y'all, this time I'll dispense with the parentheses. If you write mathematical terms next to each other, that means addition, or excuse me, that means multiplication. I'm sorry. So what do we have here? We have 4 copies of 3. We have 2 copies of 3. So right here, you actually add the exponents. You get 3 to the 6th. Okay. Right. So again, it's easy to confuse these two things, but this expression right here is something entirely different than this expression. This reads 3 to the 4th squared. And so that's 3 to the 4th times 3 to the 4th, which is 3 to the 8th, because you have 4 copies and 4 copies, which is 8 copies. Right here, it's a entirely different type of question. So you see, this gives rise to the following rule. If you have the same base, and these are some letters that get used frequently, B for base. Instead of calling it 3, we'll just call it B. If you have B raised to the m power, where m is just a counting number or a natural number, times B raised to the n power, you actually, this is really kind of a more like, I won't call it a proof, but you have m copies of something, n copies of something, so that means you have m plus n copies. Again, this is just a standard rule for exponentiation. The bases have to be the same. Now, if you have this going on, b to the m. And again, it's just a matter of recognizing the form here. If you have b to the m, the entire exponential term raised to the nth power. What do we end up doing right here? We did 4 times 2 equals 8, right? This 4, exponent of 4 times this other exponent of 2 gives you 8, and we demonstrated why that's the case. Over here, very same thing. We're just calling our b is functioning like the 3 was over there, and m is functioning like 4, and n is functioning like 2 in this example right over here. So what do we have right here, folks? We have b, and in this scenario, we actually multiply the exponents. B to the m times n. And again, when you write letters right next to each other in mathematics without any symbols, the operation is understood to be multiplication. So b to the m raised to the n is the same thing as saying b to the m times n. Okay. Again, hopefully these two numerical examples serve to illustrate. Now, one last common mistake that happens in math. What if you had, let's say, -5 squared? Okay. Okay. It's tempting right here for people to just say the squared kills the minus sign, and you get 25. Okay, people want to read this as -5 times -5, which is 25. Now that's false. That's false. That is a false statement, and I'll show you why. I'm going to put a does not equal. The little slash negates the equal sign. What this really means is -5 times 5. See what's going on? You have 5 squared, and this is called the priority of operations. The minus can be thought of as just a -1 out here. But what this really says is minus whatever the result of 5 times 5 is, which would be -25. Okay. Now, again, one easy way to see this, it gets down to readability. What is meant by this expression here? Well, what is really meant is 5 squared is what is dominating the term here. 5 squared is 25 no matter what's out here, okay? So you see that's why the answer is -25, not 25. Now, if you wrote it like this, okay, and this is where the parentheses really remove any ambiguity or confusion. If you write it like this, okay, this has an entirely different meaning. This means -5 times -5. Okay. And then in a previous video, I showed you guys why a negative times a negative is a positive. It's just a rule that a lot of people memorize, but there is a reason for it. It's not just made up. So there you go, folks. And hopefully that clears up some of the confusion about. I've seen people in advanced math classes get these type of rules confused because they memorized them rather than understood them. Okay, that's all for tonight. Thank you.